So in news, you might be generally hearing that there is a formation of huge ozone hole over Antarctica. Likewise, you might have heard. So what do you mean by ozone hole? Yes? Thinning of the ozone layer. Yes, exactly to say. Ozone hole in literally means, it doesn't mean like the formation of a hole in the ozone layer. Rather, it is nothing but, in simple manner, it is nothing but thinning of the ozone layer or decrease in the concentration of the ozone layer. So that is, in general parlance, we can say that ozone layer depletion or ozone hole. So recently, if we talk from the news point of view, like it was observed that there was a large ozone hole that has been formed over Antarctic region. Okay, so can anyone recollect which was the mission that has given this observation? Recently, did you follow any news? So there we have a satellite called Copernicus Sentinel 5P satellite. Copernicus Sentinel 5P satellite. This is a satellite that has been launched by European Space Agency. And the main motto of this mission is simply to just monitor various environmental problems. Okay, so that is the chief motto of this Copernicus Sentinel 5P satellite. So this is under environmental program launched by European Union. Okay, so recently the Copernicus Sentinel 5P satellite has observed a huge ozone hole over Antarctic region, and the extent of this ozone hole was around 26 million square kilometers. 26 million square kilometers ozone layer has got depleted. So that was the finding, and this area roughly corresponds to 3 times that of the Brazil's surface area. When we compare it into the term of a country, like, can you able to understand like how much big is the Brazil? So if you translate that, around 3 times that of the area of the Brazil, so that much would be the extent of that ozone hole. Okay, so that is one important thing. So this finding has been found very recently in 2023. So expect that there can be some sort of questions that might be there from ozone layer depletion or from that perspective. In atmosphere, it is in stratosphere. So can we expect any formation of ozone on the ground? Yes. So the ozone that is present in the stratosphere, it's nothing but the good ozone, because it tries to absorb or it tries to reflect the UV rays. So usually reflection or absorption of UV rays by the ozone layer, it is responsible for reduction in the cancers, or it protects us from some of the such kind of UV radiation likewise. But when ozone layer gets depleted, we can witness that percolation or penetration of that UV rays, and thus it may impact various things. So let's see what are the effects later on. So this is, in this context, try to learn and try to keep this concept as one of the potential concept or likely concept to be asked in exam likewise. Yes. Yes. So one important aspect that we have to keep in mind is that here, with respect to what was scientists have found that what could be the possible reason for this means, in 2023, roughly from December 2022 to 2023 January. So remember, this is another important thing that you may expect. In between December 2022 to January 2023, what has happened means there was a volcanic eruption. There was a volcanic eruption in Tonga Islands. So where are Tonga Islands? Yes, which Pacific Ocean? It is? Yes, which area? Is it east, is it west, east or south? It is south. It is actually South Pacific Ocean. Okay, so Tonga Islands is an island which is located in the South Pacific Ocean. And what has happened in these Tonga Islands? There is a volcano called Honga Tonga Honga Hapai. So there is a submarine volcano called Honga Tonga Honga Tonga Honga Happy volcano. This is the name of the volcano. So it's a submarine volcano which is located in the Tonga Islands, which are located near the South Pacific Ocean. And in this region, 2022 December to 2023 January, there was a huge volcanic eruption. And during this process of volcanic eruption, this has led and this has sent a lot of water vapor into the higher layers of the atmosphere. And it is believed that this water vapor contained lot of aerosols and lot of particles which includes, like, let's say, bromine, iodine, etc. They were there present in this water vapor. So as this water vapor reached the stratosphere region over the Antarctica, so there it is believed that this is the probable cause for the occurrence of large or huge ozone hole over Antarctic region. Okay, so that is one possible reason that scientists have put forth. Okay, likewise. So that is one thing. So remember, and one possible thing what you have to remember from this is ozone layer depletion is one concept that you have to follow thoroughly. And next thing is that what is Copernicus Sentinel-5P satellite and its functions and its activities and all those things. And other thing, you have to, for map marking point of area, so you have to look for Tonga Islands or Honga Tonga, Honga Hapai volcano. So keep all these three concepts parallelly for in this context. Okay, so that is one thing. So that is with respect to the context why we have to proceed with ozone layer depletion. Now, so we have understood basically what is ozone depletion, thinning of the ozone layer. Now, what are the causes for the thinning of the ozone layer? So there we have some substances called ozone depleting substances. So ODS, we will call them as ODS, ozone depleting substances. So what will happen? The ozone depleting substances, usually they will react with the ozone molecule. Ozone molecule means O3. It reacts with the ozone depleting substances and it leads to liberation of oxygen. And let's say if the common ozone depleting substances are nothing but those substances which contain either chlorine or fluorine or bromine or iodine. So in simple manner to say, all of them are nothing but halogens. Can you able to recollect from periodic table? Halogens. So chlorine, fluorine, bromine, iodine, they have the ability to dissociate or dissociate the ozone molecules. So it will split into ozone, and if it is chlorine molecule, then it forms like chlorine oxide. Likewise. So likewise it will dissociate. So whatever the compound that is present, likewise. And that in that way what will happen? Now there would be release of this one, and this further goes aside, and the oxygen that is present here, this may further react with another things, and that's how the ozone layer will get depleted. So that's how it is occurring. And those substances which have the ability to destroy or dissociate the ozone layer, ozone molecules, they are nothing but ozone depleting substances. Okay, so usually we are saying that these substances will have the ability. So where, in which compounds we can see these things? So that is one thing. So can you name any compounds which contain the chlorine, fluorine, bromine, likewise? Yes. Yes, good. So hydrofluorocarbons. So HFCs. you keep it aside. Okay, you keep it aside. Hydrofluorocarbons contains fluorine. Okay, you keep it aside. Enough. You are saying like CFCs, chlorofluorocarbons. Okay, and then any other compounds? Hydrochlorofluorocarbons, HCFCs. Okay, then hydrobromofluorochlorocarbons, hydrobromofluorochlorocarbons. Okay, then you just remember like methyl chloroform, methyl chloroform. Okay, yes, methyl bromide. Okay, so bromine is there, so methyl bromide. Okay, so methyl chloroform, methyl bromide, or like CFCs, HCFCs, HBFCs, etc. And apart from this, we also have some things like here chlorine, fluorine, and carbons. Chlorine, fluorine. So here, instead of this, we can expect formation of chlorine and bromine. Okay, so we will say chlorine and bromine. So these compounds which are formed up of chlorine and bromine are called as halones. Remember, like halones. Halones are made up of chlorine and bromine. Here can you able to see chlorofluorocarbons? Likewise, we will have halones. Halones would be made up of chlorine and bromine. So halones are also potential ozone depleting substances. And apart from that, we have other things like carbon tetrachloride. So this is another compound we will have. So CCl4. It is nothing but carbon tetrachloride. So chloride, Cl means chloride, 4 molecules of chloride, so tetrachloride, carbon tetrachloride. So that is CCl4. So all of these compounds are potential ozone depleting substances. Okay. Here you remember one thing that according to UNGP, do you remember UNGP, United Nations Environment Program? So it has been initiated, or it has been formed on after which conference? Yes, Stockholm Conference. You remember that. So now, according to UNGP reports, HFCs are not ozone depleting substances. Okay, you remember this is an exception, and you remember. Okay, and if you have any doubt, you go to UNEP's website, and there you can see that like we have developed HFCs instead of CFCs. Okay, so like there we have a convention called, can you able to recollect, Montreal Protocol and Vienna Convention? Vienna Convention is on control of the ozone depleting substances, and we have made a protocol to that, that is Montreal Protocol in 1987. So in that we have resolved to stop or reduce the production of this CFCs, manufacturing and use of the CFCs we have reduced. And during that time, when we are just reducing the manufacturing and use of CFCs, we need to have an alternative. So that alternative we have picked is CFCs. Sorry, HFCs. Okay, HFCs is the alternative that we have picked for CFCs. So there, we have felt that HFCs are not the ozone depleting substances, and we have started using them. But eventually what we have found out that HFCs have global warming potential. They are global warming gases, that is greenhouse gases. And thus in 2016 we have done an amendment to the Montreal Protocol, that is nothing but Kigali Agreement. Okay, so we have taken up another agreement called Kigali Amendment. Kigali Amendment. And in the Kigali Amendment, what we have done, we have resolved to reduce the HFCs by and around 80% to 85% with respect to various countries by 2045. By 2045, we have resolved to reduce around 80 to 85% of the HFCs, which are potential greenhouse gases, which has the potential to cause global warming. So that is one thing. Okay, but here be clear that they are global warming gases and they are not ozone depleting substances. Okay, so this one thing you have to keep in mind. one chlorine molecule, one chlorine atom has the ability to destroy roughly 1 lakh ozone molecules. This is the impact. This is the level of effect. So that's why one chlorine is the best ozone depleting molecule. You remember that chlorine has that ability. So that's why, like when we were replacing CFCs, not CFCs, HFCs. So we have replaced that, and fluorine has less ability and chlorine has more ability. So you remember, like, so that is one possible reason, but not the sure reason. But you remember chlorine has, this is the ability of chlorine to destroy the ozone. So that is one thing you have to keep in mind. 1 lakh ozone molecules it can destroy. So that is one thing. So here when we compare the ozone depleting ability of CFCs with that of HCFCs, CFCs will have the greater ozone depleting ability than HCFCs. Okay, so chlorofluorocarbons will have greater ability than hydrochlorofluorocarbons. So that is one another thing that you have to keep in mind. And when we compare with this, we can say like we can say that like usually least thing is HFCs. And according to UNEP, HFCs are very weak ozone depleting substances, or we can classify them as non-ozone depleting substances. You can remember likewise. So that would be the scale. On scale, you can remember likewise. Ozone layer depletion. One important thing is release of chlorofluorocarbons into atmosphere. So how they can be released? So there are various sources for this. CFCs and all those things. So let's see what are the sources for that. Okay, and where you can see liberation of chlorofluorocarbons. Yes, one important source is refrigerator, and other important sources is air condition. Things like air conditioners, or like you can expect like the refrigerators, or things like aerosol propellants. So can you able to recollect aerosol propellant means? Like the sprays, perfumes. So when you push it, then perfume will come out. So it is propellant, aerosol propellant. So you can see that is one another area where you can have. So all of these are nothing but the sources of chlorofluorocarbons. Okay, so that is one thing. And then next important source is like one is with respect to release of CFCs, or simply to say ozone depleting substances. That is one cause. And then release of nitrogen oxides or nitrogen compounds into atmosphere. So this is another impact, another thing which may cause ozone depletion. Like we have various nitrogen oxides like N2O. What is N2O? Nitrous oxide. And we have NO, nitric, or simply to say nitrogen oxide. And we have NO2, nitrogen dioxide. So release of all the nitrogen oxides have the ability to destroy ozone. So that is one another important thing. And then next important source or next important cause is like unregulated launch of rockets. Unregulated rocket launches. This is another important source. So when we launch the rockets, so during this process of combustion of the rocket fuel, so there it releases a lot of ozone depleting molecules, like let's say iodine, chlorine, and water vapor, which further consists of such kind of pollutants. So unregulated rocket launch is another important cause for ozone layer depletion. And then there are some of the natural causes also. So if we talk from the perspective of the volcanic eruption, there is every possibility that volcanic eruptions might also lead to ozone layer depletion. So like what has happened in 2023, the same is the example. Okay, so that is one thing. And then forest fires. So forest fires also may release lot of air pollutants into upper layers of the atmosphere where they may reach the stratosphere, and there we can expect the ozone depletion. That is one thing. And have you heard of some things called sunspots? Sunspots. So sunspots are another important source of ozone layer depletion. So sunspots are nothing but the dark areas which are present on the protosphere of the sun. Okay, so these areas are also one of the potential cause for the ozone depletion. And apart from this, we have other things like stratospheric winds. Stratospheric winds. So usually, if you talk from the stratosphere, we can divide stratosphere into two layers. Can you able to recollect that? There would be one layer which would be static, and one layer where we can expect the flow of air. So upper layers would be generally it would be static, in the sense there won't be any flow of winds and all those things. But in the lower layers of stratosphere, we can expect some winds may blow. So such kind of stratospheric winds that may reach the upper layers, or that may, if excessive stratospheric winds are there, they may further has the ability to destroy the ozone layer. Okay, so that is because it will blow the ozone, and thus ozone would be removed from that area. Okay, so that is one another important thing that you have to keep in mind. Yes. Sunspots are nothing but dark areas. So dark areas, and in one particular area, what will happen there, you can see the presence of dark areas in the sun, and the surrounding areas would be very very bright, and they will release solar flares. And these solar flares that are emerging or that are emitted in and around the sunspots, they may lead to dissociation of ozone molecules.